In this video, I'm going to go ahead and be replacing the rest of the relays on my Tektronix TDS 784A oscilloscope. And the reason for that is because a couple of these relays went high resistance. It was actually causing weird offset issues with channel 1 and 2 mainly. And I already went ahead and replaced the relays on those, and it completely resolved that issue. So now I'm going to go and do channel 3 and 4 and go and replace the relays on video so I can show you how to cut them out, desolder the legs, and solder the new ones in with less risk to damaging the pads and traces on those hybrid modules. And the reason for that is because they are ceramic, and ceramic does soak up a lot of heat. So if you're not careful, you'll likely lift the pad and also the trace along with it and end up destroying the hybrid modules on these. So be extremely careful when doing it. And this job does require a very good solder station and a good micro pin. So I use a micro pencil because you can easily get under and around the relay without melting the casing and so forth, and it does a great job with it. But I am not responsible if you do damage your hybrid modules or your oscilloscope from watching any of my videos. So take cautious and just be very careful when doing it. If you can't do it, then get someone else to do it for you that can. Now, first thing of course is you will need the relays, and then here's the old relays, the ones I pulled out channel 1 and 2, and you can see there the numbers. And then these here are the replacement relays for them. There's 4 in each hybrid module. You're gonna need a total of about 16 to do all the channels. And first thing you gotta do, which is the obvious thing, is remove the acquisition board. And there is screws on the front as well that you do have to remove in order to slide this board out of the casing. Then the next thing after you do that is then you do have to remove these screws on top that actually hold the whole attenuator assembly onto the board. What I like to do is I usually go to center screws, then I go to outer screws, and then I go to inner screws. Therefore, you're keeping even pressure as you're removing it and stuff like that, and you don't have too much pressure on one side where you have no pressure on the other side. And same way when I go ahead and torque the screws down, I torque them down in a pattern so that way it keeps even pressure across the whole entire attenuator module when you're actually screwing it back in there, and it makes even contact with all the contacts going to the attenuator module to the acquisition board. So that's the first thing I'm going to go and do, is I'm going to go and remove this out there, and I'll be right back once I get this completely unscrewed off the acquisition board. After you get done unscrewing your acquisition board off the attenuator assembly, you're go ahead and move your acquisition board to a safe spot, and then you're go ahead and remove both these contacts here. Be careful not to directly touch those, by the way. Just go ahead and grab it right here corner where there's no contacts, and then go ahead and put it in a safe spot pretty much where it's not going to get damaged or anything like that, and it's out of the way. Okay, after you get done doing that, it's going to reveal your 4 hybrid modules. So what you're going to have to do is desolder this center lead right here that goes to the center pin on the BNC connector. And simply all I do is I just go ahead and heat it to appropriate temperature, and I go ahead and actually spring it this way, and I spring it towards the actual BNC jack, so that way then you can just simply lift this module straight out without having lifted at an angle or anything like that. But be very careful when lifting and handling these hybrid modules. Try not to touch the contacts on there, and also don't use a screwdriver to lift that up. They do come out easily. Usually you can just tilt it and they'll slide right out and stuff like that. You don't want to crack those, because if you crack those, you're going to have a very hard time and they're going to be very expensive to replace. So I'm going to go and desolder these two because I already did these 2 channels. So I'm going to go and do the 2 remaining channels, and I'll be right back with you once I get one of the channels out at least. So I went ahead and desoldered the 2 center leads that go to the actual hybrid module. And what I did was, you can see I kind of springed it this way here so it's away from the board. And now I'm going to go and take a card here and just simply use it to lift the board out, because I don't want to necessarily touch the contacts too much as possible. And then you go ahead and just lift it completely out, and now we're ready. Go ahead and cut those relays out and pretty much replace the relays on that board. So I'll be right back with you once I get to that point. Here's one of the hybrid modules, and you can see there's 4 relays, and those 4 large yellow relays are what we're going to be replacing. Now the method I like to do is I like to actually cut the relay out, and the reason why I like to cut in the middle of the lead and remove the body of the relay is because then that way you're putting less stress on those actual pads, and then therefore less risk of actually lifting or damaging anything as you go and do that. If you go ahead and try to desolder that relay as it is, you can end up causing severe damage to the hybrid module. So I find usually just taking your diagonal cutters like this, go ahead, tilt it, go ahead and be careful where you're looking, and then go right at the top part. And it's very important you get it towards the top and not all the way towards there, because you'll put less stress. And just snip, alright? And you go ahead and snip there. And you go ahead and snip where you can snip around. Okay? I can see already the problem with one of these was it wasn't even soldered onto the board. It actually had a cold solder joint on there, so it might have not even been the relay on this one. It was the fact that there was a cold solder joint that was actually causing the issue. But you get the idea. You're just snipping each of the leads all the way around till you go ahead and remove all the relays. Just go to where you can access to, and then go ahead and put your diagonal cutters at a good angle. Try not to push up as you're doing it. Just go and do a light clip, and then you can go ahead and remove all the relays. So I'm going to go and do all of these very carefully, and then I'll be right back once I get the relay bodies removed. So once you get done cutting your relays off your hybrid module, this is what it should look like. And as you can see, there is no damaged pads or traces on this board because I went ahead and cut the relays out versus trying to go ahead and desolder and lift the relay, which likely would have resulted in a damaged pad or trace. Now the next step is, of course, to actually go ahead and desolder the remaining leg and clean up the pads and so forth of any solder, and then go ahead and retin those pads, and then go ahead and install the new relays onto this hybrid board. Now, as I was cutting the relays out, I actually found out what the problem was, and you can see here where these legs are longer right here was, and here's one, you can see how that leg's long. It wasn't even really soldered onto there. What happened over time, it cracked the ring around those solder joints right there and wasn't making good connection pretty much. So it was actually cracked solder joints that was causing the problem on this particular board. I am replacing the relays with new ones. I did the first 2 channels already, so I figure I might as well go ahead and do them all. But probably soldering those cold solder joints likely would have fixed the problem as well too. So you may want to check that on yours and look for any cold solder joints and just go ahead and resolder those if you do have any, and that might actually resolve your problem. You may not have to replace the relay. In my case, I wanted to replace the relays to put fresh set of relays in there, and then that way I know that the contacts in the relays itself, even though they are sealed, they still do end up oxidizing over time and stuff like they are from use just wearing out. So I wanted to go ahead and replace all those anyway. So when soldering ceramic, like I said, you do need a good micro pencil like this that has good thermal recovery, where the sensor's actually in the tip and not like down here somewhere, so that way it has quick thermal recovery, and therefore you'll be putting consistent heat on there and be able to actually solder and desolder off ceramic, and it won't likely damage the pad or the trace so long as we're careful. So I'm going to go ahead and do that, clean this board up, and I'll get prepared to actually solder new relays on this hybrid module. So I went ahead and finished removing the remaining legs off the pads off this hybrid module, and also cleaned the flux off the board as well. And this is what your board should look like too after you get done. And as you can see, no damaged pads or traces, and the pads are nice and clean and ready to go ahead and put new relays on there pretty much. Now I did go ahead and cheat. Instead of using the pin soldering iron for that, I went ahead and used my 120 watt solder iron for that, because the tip of course is much bigger, so therefore it's going to have better tip contact. And I just went ahead and pretty much took a piece of wick there and went ahead there, and then I went ahead and just cleaned the remaining solder off there. and therefore it did a nice job because I was able to keep even heat across that pad, and I was able to go ahead and remove the solder off that pad without risking any damage. So, but you do of course require a very good solder iron. Don't use those cheap Chinese solder iron, because the problem with those is they're not spec'd right, at least as far as the tips go. And the tips sometimes are loosely fitted around the shaft on those cheap Chinese solder irons, and then therefore it doesn't heat evenly the tip. And when you go in, especially with ceramic where it soaks up a lot of heat, that could cause damage of course to the pad and stuff, because it's not heating it quite right, and then also doesn't have a quick thermal recovery and stuff like that. And that's how most people end up damaging these. Always use a quality solder iron when you're actually doing, especially when you're soldering on ceramic. I can't stress that enough. But I'm going to go ahead and get the new relays on here, and I'll be right back with you once I'm done. So went ahead and installed the first relay on this hybrid module, and that's the first one that I installed. And I'll show you the order real quick which I installed them in. And it's very critical you get your order right, because you got to be able to access all the leads and therefore minimize any damage of course to melting the body of the relay itself and being able to access those leads. So I usually do it in this order here. That's the second one, then the third one goes right here, and then the fourth one goes right here. So I do this one, this one, this one, and then this one in that particular order, so that way I have full access to the leads as I need. And then therefore the only one that I really got to go under is this one, and I actually use a very micro solder pin to do that, so that way I don't touch the body of the relay, therefore melting something, and be able to still access that middle lead that I need to access to without actually damaging the body of the relay and stuff like that. You got to be very careful with this, and you got to be able to have no shaky hands and stuff as you're doing this work. Now as far as the solder that I'm actually using a silver alloy solder by Keister, and it's probably one of the best solders. It's actually also lower temperature too, and very good for soldering on hybrids. So as you can see, that's how it looks after soldering. Let me see if the camera can focus in on that. And that's what you want. You want a nice shiny appearance to it, and all the way around the leg of the actual relay itself. So that way as it vibrates and stuff like that, it's not gonna crack. It may crack years down the road like the original ones did though, but at least your repair will last a while, and should last as long as the original ones did if you do it properly. So now I'm gonna go and get the remaining 3 relays on this board, and I'll be right back once I'm done. So went ahead and installed all 4 relays onto this hybrid module, and the solder iron I actually used to do this was this WXMP-MS, and it's a micro pencil. I love that solder pencil because it just does a great job and can get into angles and stuff like that where most solder irons can't get into. Like, you can't use something this big to get into. You're gonna wreck the board essentially trying to use that. Now the other solder iron that I use is also JBC NAS, which I actually use for iPhone board repairs and stuff like that. You can also use it also to fix these hybrids as well. But I really don't expect anyone to have those, because that's a $1,200 solder station, and this roller is also about $1,200 too once you get the tweezers and stuff like that too with it. So they're not cheap, but you get what you pay for. And I do a lot of micro soldering stuff like that and board level repairs, so I really do need a really good solder station. So that's why I spent the $1,200 on it, and also spent the $1,200 on the JBC as well. So the way your work should look like after it's done, it should be nice and clean. Should also clean any flux and stuff like that you have on the board. And like on this one, no damage traces, no melted relays. That's how the end result should be. So I'm going to go ahead and do the other one, and we'll get it back in the scope and see how it works. One thing to note is you do have to put thermal paste right there, because it does transfer heat from the hybrid module to this casing as it acts as a heat sink. So make sure you go and put 2 dots of thermal paste back on there. Went ahead and finished reassembling Tektronix TDS 784A oscilloscope after repairing the hybrid modules on all the channels. So I'll just go and demonstrate that it does work. And that's alright, let's go to channel 2 now. Okay. We'll go back to channel 1 and we'll go and feed a signal in it now. Okay. There you go. And we'll even do the measurement function while we're at it too. Alright. Okay, then we can just remove all measurements. Alright. And then we'll go and select the measurements here. We'll do frequency and amplitude. And there you go. So now we want to remove the measurements. We could. And then we'll go ahead and just remove measurements or remove them all. And now let's go ahead and feed in the modulation. Alright. And then we'll go and turn on peak mode. The scope does have, and we'll slow it down quite a bit. Okay, and then we'll adjust the trigger, and there you go. And then you can see it works on channel 1, so we'll turn that off and we'll go to the next channel and we'll set the channel trigger to channel 2. Snare, and of course turn off channel 1. Alright, there you go. And you can see it works correct. Okay, we'll turn off channel 2. Select source to 3. Okay, and of course turn on channel 3 and turn on the signal and modulation. Okay, now we'll go to channel 4, turn off channel 3, source is 4 of course now. Turn on that, and there you go. And I went ahead and did a few tests on it, including probe compensation and all that, and this scope's pretty much dead on spec too, so it's working now correctly on all 4 channels, the trigger's on all 4 channels, and the scope works and pass all self-tests now, so the scope is fully functional. The only thing I really got left to think about is what I'm going to do about the CRT. If I'm going to keep the original CRT, I'm going to upgrade this down the road to an LCD. The CRT is bright, it works, it does have blotch right here because there's actually liquid in between that LCD shutter and the CRT display itself, and that liquid ends up deteriorating. It causes blotches and stuff like that that's shown on it. You can't really see it. It's not that bad, it's not that annoying. Let me go and pull up a menu. Let's go ahead and do that. And you can see right there, that pink dot right there. And that's pretty much the problem, so it's not bad. I'll probably just wait till the CRT dies before I go and decide to do the LCD upgrade. I mean, the scope is low hour, so the CRT is pretty bright, and it's also pretty readable. It really doesn't affect anything, so probably just keep it as it is. Plus I got it hooked up to my monitor, so I can use the monitor to also look at it too, which I use mostly anyway. So there you go, and this concludes the video of the Tektronix TDS 784A relay replacement on the hybrid modules.